Okay, we're Mountaineer DAC, and our project was the Black Fox Data Recorder. I'm John McCarthy, Anthony Rotolo, John Tamalashi, and Adam Trainer. We're going to talk about the problem, why we chose the project, summary of our hardware, the guts of our box, give you a software summary, and then talk about the challenges we face. And then
Sean, we got our problem statement from Sean Banerjee, who is a PhD student here. He does a lot of autocross races, and he wanted to take data from his car to improve, runs. He came to us and said, I would like certain things measured. He gave us a list of what he wanted measured, and then we created this system based on his requirements. We got steering angle, brake position, throttle position, G-force, oil coolant temperature, and GPS to track the car's position over the track.
One of the biggest issues with the systems that are already out there is they're very expensive and they're not very easy to use. They're not very user-friendly. So that was one of the things we really wanted to try to do with ours, and make it very user-friendly and relatively cheap as compared with what's already out there.
The other thing was, with a lot of the systems on the market right now, if a driver wants to do some type of upgrade or change their system in any way, they really can't. Everything's pretty much locked. You can't modify your system in any way. And that's what's kind of nice about ours, is we're leaving it open. Everything's going to be nicely labeled, so if the user has some type of technical background, they can figure out quite easily how to add different sensors if they wanted to. We also have some auxiliary ports if they want to add additional sensors.
The heart of our box is the Dragon 12 Plus development board, and some of the devices we have to get us the information we need use the time accelerometer, GPS chip. We also need a regulator circuit for our power supply when it's in the vehicle, so it doesn't set the voltage is right. We have 7 total sensors. 3 of them are analog potentiometers for brake and throttle and steering angle. We also have 2 fluid temperature sensors.
These are the connector ports. 2 are, like we said, are for the temperature sensors. The other 3 are for the potentiometers. This is a top view of our box. We have external switches, so different messages scrolling at different times. So, I mean, you wouldn't recommend the driver to look at these while they're being used, but they help when programming. And
the masking gauge is just temporary for now.
Actually, with the driver, I mean, that's the only LCD screen we have on the box right now, but we could actually have another external screen specifically for the driver. So beforehand, with those switches, he could select exactly what he wants to see before he goes out for his run.
This is the inside of the box. You can see each of the connectors wired up. This right here is how we get power to the board when we test it in the lab. And then it's hard to tell, but right here is our regulator circuit. And you can probably see this on the top view before. There's this black thing coming out of the box right here. That's a 1 amp fuse. So if for some reason with your engine spiking, if there is some type of voltage spike that causes the current to go above 1 amp, this will blow and it will kill your processor. Here's our, that's how we get it from the car adapter. Here's the
Accelerometer is up here, mounted right on top of where the SD card slides on the side. And then you can see all the 5 connectors and how they're on the breadboard. And then today there's some analog ports on here, and then these switches. Then we have our 2 serial ports over there on the left.
We use 1 serial port primarily to upload our for the board. And then the other one, it's not pictured here, is our GPS. And we've had that connected to the secondary serial port.
We also use one of them, we can dump data live to Visual Studio application.
And we've gotten real-time graphing off of that. So like, if you hook this like directly to your laptop and you like slam down the brake, there'd be like a real-time graph of your brake position.
And you see a spike.
These are some of the connectors.
The bottom picture there is actually, we built a demo cockpit for the senior design fair, and that's our pedal setup. And then the top picture is the, what you couldn't see from the top, is that's actually where the SD card inserts into the board.
We have a card reader. This is how we're currently doing it, is that data is going to be stored to the SD card, and after a run, you pop out the SD card, you put it in the card reader, and then we have a user interface that rips all the data into a